Hey guys, welcome to our first podcast, DATA-2-DECISION. So in the series of podcasts, we'll be talking about topics around how does different organizations, different institutions employ data and convert it into meaningful decisions. We'll also speak subjectively about what kind of different technologies come into play and what kind of concepts work into place to ensure that these decisions are going into real world. So in the first episode, we have Alok, who is a lead data scientist at Udan. We also have Pranjal, who is another lead data scientist at Udan. He used to handle fraud and abuse. And we have Akshay, who is a data engineer, and he built the entire data platform for Udan. So I'll actually let Alok introduce himself to start with the conversation.
Hey, hi everyone. I'm Alok Patel. Right, I've been with Udan for close to 3 years now. So if I talk about my journey to data science, right? So I did my bachelor's in mathematics and computing, right? So that gave me exposure to mathematics, statistics, and coding, right? So after that, I realized that I really like coding. So I thought applied mathematics will be right fit for me. So I did my master's and PhD in OR from IIT Bombay, right? So after that, I joined like data research. I was there for 1 year. Right. Then I joined another company called ExxonMobil. Right. So that is into oil and gas. There I used closely work for like 3 years. So till now I have experience slightly more than 7 years. Right. And entirety of that experience I have been working on like different kind of supply chain logistics routing kind of problems. Right. So I use different kind of data science and machine learning algorithms to solve like routing problems. Yeah.
Awesome. Pranjal, would you like to?
Yep, let me go. So, hey everyone, I'm Pranjal. I started working at Udan almost 3 years back, almost at the same time period as Alok. Although my journey or is slightly opposite to what Alok said. So I joined as a BTech in computer science at IIT Kanpur. I think in the second year I realized that probably coding is not my cup of tea, and it would have been very difficult to stay in computer science without not liking coding, right? With if you don't like coding. So then I started taking a lot of electives which were related to AI, ML, vision, NLP, right? All those areas which were buzzing at that point of time. And then there was a point of time when I decided that okay, probably I should either pursue masters in this area, or because taking a job with just BTech and not liking coding was very very difficult. So I converted my degree actually to a master's program. I did thesis in NLP. I worked a lot on embeddings at that point of time. Then I took a job right post that, and yeah, after that almost 8 years now in ML and DS. In terms of work, apart from Udan, like I have worked with Ola, Visa, and a startup which was working in API security. Problem statements which I have worked with throughout these years have been like customer segmentation, fraud and abuse prevention, which I've been working very intensively at Udan. API security, some bit of upselling, right? Upselling products using ML. Yeah, so that's about me.
Awesome. Akshay, do you want to
Yeah,
go
sure.
ahead?
Yeah. Hello, everyone. So my name is Akshay, and I am currently working as a lead engineer in data platform team for Udan. So it's almost 2.5 years. So basically, we all are almost at the same experience in Udan, and fantastic journey over here. Majorly setting up the data platform and basically getting the customer feedback, building the things which are relevant for all the data users and consumers. Before this, I was working in data platform of two more startups, well-known startups basically in India. One was PharmEasy. There I was working in the data platform team as a lead data platform over there for 2.5 years, and basically 2 years and 2 months. And then prior to it, I was working with Ola for 1 year and 2 months over there in their data platform. So I think I and Pranjal both worked in Ola at some point of time. And so basically overall 6 years in data domain, and then there is 3 more years of experience in a different domain, entirely different domain. So basically it's a discovery for me to come to data domain. And I am a graduate in electronics engineering from AMU. So yeah, basically it.
Got it. That's interesting. I didn't know about the last part. Cool. So I think so. First, in this conversation, we'll start with the problems that people usually see with respect to how we convert data into decision, as I mentioned, and we'll start with a specific funnel. So Pranjal, like you have been at Udan solving fraud abuse and a lot of other use cases in the past 3 years. Can you be specific about like pick a use case and how do you go about doing things in Udan? So data comes in, let's say through some pipeline, and you have the data with you. What is the process that you usually employ to convert the data into a meaningful decision?
Yeah, sure. So I think the approach is, I think it's like a template which I believe most of the DS folks follow. So it starts with just getting a dump of data and understanding, okay, what is there, what is not there, right? And even before that, let me also talk about it. That for a data scientist, how it has evolved over a period of time is that, as you said, right, it has to be a data-driven decision. Now, earlier when data science just started, people used to make decisions in silos, right? They just built models, uh, deployed models, and that's it. Now a data scientist role is more nuanced, right? People have to talk to different stakeholders, gather the requirements, and translate that into a solvable data science problem. It could also mean just splitting the problem into multiple small problems. So as soon as we get a data, right, the first responsibility is to just get a sense, okay, whatever we are trying to build here, do we have all the relevant data points available? And when we started at Udan, actually a lot of data points even did not exist, right? So all it started was with getting those instrumented, be it in the app, be it on the data platform side, right? Wherever it is possible. Once you have that itself is a long journey. I'm just cut shorting it. So once that is done, the next step is basically data quality, because even though when we have a lot of data points, some of those probably might not be meaningful because of the presence of a lot of null values, something which is beyond the normal range, right? Data range. So after that, the journey of a data scientist actually begins, right? Which is doing a lot of feature engineering, whether those features which you have created are actually going to impact your end result or not. And if I'm talking about feature engineering, I think one of the very core things, or one of the very important luxuries we had at Udan was we had built the feature store in this due course. Right? Probably we'll come to that in later point of time. Yeah, that's the feature engineering. I think that itself takes, like, this whole journey itself takes more than 60 to 70% of the time. And then another important point probably which you have to decide is whether this model is going to emit results in real time, or is it just that the end consumer is going to consume the outputs in a batch mode, which is, let's say, every 24 hours, 1 month, or whatever it could be any duration. And as per that, you have to build your model. Now if it's a batch, then probably the latency is not a very big constraint, right? And you can obviously go ahead and build any complicated model. But if latency is a constraint, then the different set of model choices kick in, and then you have to build it accordingly. I'll just give a very simple example, right? So let's say if you have a very small latency, then probably a complex model such as a graph, although graph neural network models do work in real time, but then the type of data and the type of feature engineering you do is very different. So you have to select that probably the graph neural network is not going to be my cup of tea in this problem statement, and probably just take a very basic model, or model such as random forest and things in place, right? So yeah, that's the model decision. How do you want to build?
So let's I think for if less tech savvy people are watching this, then for them, let's take an example. So let's say I have through and ordered box of iPhones, and instead of iPhones, I've gotten bunch of rocks, right? And similarly, there might be a ton of other customers who might have genuinely faced the issue, or there could be few customers who might have faked it, like I've actually gotten iPhones, but I've said that I gotten rocks, right? So assume that this is the problem statement. So then how does the data actually travel in and get into the stage where you are pre-processing it, generating the features? So let's discuss that part first.
Yeah, so for us, data largely comes through, I'll call as 4 different sources, although probably a few of them are related. One is whatever we have stored in the past, and in Udan we store it in a delta lake format, right? So that's like the old historical data. Second is some of the use cases requires us to consume external CSV files because a lot of teams don't work in probably don't interact with systems, so that data is not systemized. So they typically work in Excels and all. So you have to be ready to consume CSVs. Then the third is a stream of events. These events typically come from the app. Let's say you want to track session history, right? A person who is probably trying to do fraud, they'll just take the order, or they'll just receive the order when it is delivered and just return it instantaneously. So you'll have to look at those time durations, what is the activity on the app and all. And then fourth is probably the API call, which is basically which is calling your model, right? That also gives you some kind of data inputs for the model to consume. So I'll categorize this into these four buckets.
Right. So what essentially is also coming out is the real-time app events that are signifying the behavior just before the order placed. That is very vital for this pipeline in this specific example. Got it. And also,
it is very important for fraud as well. I'll say that is one of the most important, because a lot of frauds we have seen historically are very fast moving, as in they just order within like span of minutes, right? Few minutes. And
right.
If you are not capturing those stream of events, probably you'll lose out on the money.
I see. Got it. And so in Udan, how have you probably handled this fraud? Like, do you have real-time flows that go into solving these problems, or do you have batch workflows where you do post-order phone calls and all these sort of concepts to track fraud? How do you do it?
Yeah, so the answer to that is not a single answer, probably. So it is a combination of both batch as well as online, because a lot of batch models, right, which do the processing offline, their end output is being consumed by the real-time model. So in data science terminology, we typically call that as priors, which is like the prior information we have available, right? So let's talk about simple buyer fraud, right? So you want to know, okay, what is this buyer's return history? As simple as that. Now you cannot compute it in real time. So there has to be a lot of offline competition, and plus some models which basically do some kind of calculations on top of it. Now the second is the online, right? For example, there are a lot of flows which basically predicts in real time whether this order is going to be a fraudulent order or not. Now in that case, the input is both these batch model output as well as all the stream of events which are flowing in.
I see. Got it. So
in terms of consumption, also consumption, as you said, right? Calling. So there are multiple ways to consume. It could be consumed by a second system, right? Which is more like a downstream system, or it could be consumed by a team, which is basically, let's say, calling these buyers and understanding whether they really want to do, whether they are genuine buyers or not.
Right. Got it. So and coming into the model part of it, right? Like data is okay. I think the idea is clear. So like if there are a ton of models out there, right, and ton of frameworks out there. So if I'm to go about building let's say a fraud detection model or some other model, then how do I go about choosing which model do I use or which framework do I use? Or do you usually bank on somebody else who has done this journey and then take their learnings to employ this? How do we go about doing this?
So I think the I'll not call it the right, but the best approach which has worked for me personally is setting up a baseline first, which is basically as simple as like a model such as a regression model, right? And then basically doing some kind of paper research, right? Paper reading, understanding, okay, what is the right way people are solving this problem. Now that could mean like implementing bunch of different models. Now, once you have figured out the baseline as well as the best model for this, then comes the point of choosing the right framework. Now, in this journey, you already know, okay, which are the models. Then probably sometimes there will be a trade-off. Okay, probably this building this framework itself is going to take some time. Then you just fall back to a less efficient model, I would say. So yeah, selecting the model, doing the right research work is important first, and then doing the framework.
Got it. And I think it will be an iterative journey as well, right? Like as you said, baseline, you use it, learn with the data, and then take the feedback.
Yes. Again, the same fail fast approach also works here. We have to just do it very, very quickly, all the iterations.
Got it. Sounds right. So how do you actually see this space evolving? Like now we have more mature models. Obviously, LLMs have come in with ChatGPT, Claude, Llama 2, ton of other things, right? And there are use case specific LLMs that are coming in as well. So, do you foresee a change in how these problems will be solved in the future? Like, rather than you training a regression model from scratch, would you be banking on these pre-trained models, just fine tune it for use case, and then would they perform better?
Yeah, so I think even before LLMs, right, AutoML started to mature. And how I see this going is probably AutoML frameworks, right? Because a lot of problems cannot be till it's solved by LLMs. So they will both go parallelly for me. And AutoML probably will mature from this point of time. And that is going to help a lot of DS folks as well as non-DS folks to get a hold of ML and solve their problems. So that's how it is going to evolve for me. And yeah, again, if I were to talk about GenAI, there are a lot of different things, right? For me today, GenAI helps me actually write the code very, very quickly. So even if it is as simple as writing a regression model, I need not just go out and copy paste from somewhere. I can just call ChatGPT and write a skeleton code. So that's how it is going to help me. Probably in the future, you just say, okay, probably this is the problem statement, and just it gives you the end output as well.
Yeah. Fair. So it's right now very good as a productive tool.
Yeah, exactly.
Cool. That sounds great. So Alok, actually, let's try to understand your use case.
Sure.
I have interacted with you before, obviously, so
Yeah.
I know very less about ops research.
Yeah. Operations research.
Yeah, operations research. Yeah. So basically, it is to do with supply chain, and you are optimizing the way supply chain behaves, last mile, and all these things, right?
Yeah.
Could you high level describe, like, let's say, the person who is looking is me, who doesn't understand this at all? Can you describe it?
Yes. So, like, as the name suggests, right, it's try to optimize operations, right? So it could be that you are trying to maximize efficiency or throughput, right? Or you are trying to, let's say, minimize cost, right? So generally, operations is not only into supply chain, right? It is everywhere. So if you go and talk to any companies, right, everyone use operations research in some form, right? And in most of this data science model training and other thing also, right, in the backend, you need to solve an optimization problem, right? That is also operations research, right? But yeah, but like historically, right, the classical OR examples are mostly in supply chain logistics routing kind of problem. So that's why like people think, right, whenever we talk about operations research, it is mostly into supply chain or logistics.
That's interesting. Can you take a non-supply chain example? Let's assume we are using, let's say, a pharmaceutical company like Biocon. It might have a ton of internal things, right, apart from logistics. So, would you suggest, like, what would operations research involve in a company like this?
Okay, so yeah, so if you are talking about, let's say, a pharmaceutical company, right? So now just think about this budget problem, right? So they have some amount of budget, right? And they can use that budget to, let's say, set up 2-3 new facilities with different kind of machines, and those machines can do certain things, right?
Right.
So, and they will have, let's say, some demands for each of these products that those machines can produce, right? Since now we have limited budget, right? You can do only certain things, right? So how do you find what is your optimal setup, right? So to solve this kind of problem, you need operational research techniques.
Got it.
Optimization, simulations, yeah.
I see. Then I think this direct application might also be industrial production, right? Like if you want to optimize production.
Yeah. So like I did my master's and PhD in industrial engineering and operations research. So yeah.
Okay. So then I have a ton of questions here. Let's say we are FMCG is something that everybody relates to, right?
Yes.
Let's say we are manufacturing lace.
Yes.
So then, like, what would it even involve, and to what degree do we optimize production of lace? There are 4 different flavors. Let's assume, right?
Yes.
Green, yellow, blue, red. If I'm the colors, right?
Yes. Yeah.
So then, like, let's assume that we are to manufacture 500,000 packets per day.
Yes.
At a factory capacity.
Yeah.
So how would we improve that with operations research?
Yeah, so actually you can include the like distribution problem also with this, like with manufacturing, right? So let's say you are operating across India, right? And you know in different market, right? What kind of demand you have for like different colors of lace, right? And you have different facilities across India. They can let's say manufacture like different package sizes and let's say like different colors of lace, right? Now, given the supply and demand,
Right.
right? How are you design your like production planning, right? On what date, in which facility, how much of which color lace you should produce, right? So you need answers to all of these questions, right? And at which facility you will be storing what quantity of which color lace, right? So operations research help you kind of find optimal solutions to all these kind of questions. So when you talk about operations research, right? So it is mostly data-driven decision making, right? So use your, let's say, this kind of forecasting data and your capacity data, right? So that you can better plan your distribution or manufacturing.
If we are to speak about, let's say, handling supply chain, I think you have worked in Udaan. So what
Yeah.
kind of problems do you deal with at Udaan?
So I would say, right, if you talk about supply chain, right, so there are like different stages in supply chain, right? So if you just want to talk about, let's say, your like delivery network, right? So from the time you pick, right, to the time you deliver the product to your end customer, right? So there are like different stages involved, right? So that first part, right, for picking from your let's say like we pick from somebody, right? So from there to your that hub, right? So we call that fast leg is that fast mile, right?
Right.
And then
Right.
and then from your, let's say, one hub, right, from where actually you do the deliveries, right? We call that as a last mile hub, right? So in between from first mile hub to this last mile hub, we call as middle mile network, right? And then you have, so at any given point of day, let's say from Bangalore, right, we have thousands of orders, right? Then we need to decide, right, how many trucks or what kind of vehicles we'll need, right? Who will serve which set of customers, right? So that will come into the last mile side of thing, right?
Got it.
So this is only one part. Then again, if you think about like how are you going to design this network, right? Where do you want to set up your facilities, right? Where should be your transshipment center? Where should be your last mile hub, right? So all this kind of decision making that comes into operations research.
Right. And also, I hope like this will deal with, let's say you have a vehicle which has certain capacity. How do you
Yes.
fit these goods into those slots so that the machine is
Yeah.
properly
Bin packing. Yes. Yeah.
interesting?
Yeah.
So I think there are the
Lot
use
of
case.
things. Yes.
Yeah.
Endless. Yeah.
Great. So now actually let's get into the data part,
Yes.
the pipelines which power all these decisions.
Yes.
Okay, so I think you have done data platforms for past 6 years. You must have seen like ton of technologies that are there today, were there, not there now. A lot of different things, right? So before we get into all the specifics, first question would be, what has been the most basic ask for a data platform? I think there are two customers here itself for you.
Correct. And I think they will also agree the most basic ask would be the availability of data and the quality of
Yeah.
data.
Yes.
So that is the most basic to the most granular level. They would like to see their data in the data platform, and they want it to be of good quality.
Yeah.
Not of high quality, they want it to be of at least good quality, so that they can start working on their use cases as early as possible. And another thing would be the durability. So basically, they want their data to be there in the data platform for long duration, so that in the future, if they want to analyze on the data after 1 year or 2 years, also that should be available for them to be working on, right? And then there are a couple of requirements from infra side. So, for example, they want their data to be so they want to basically have the self-serve sort of capability in the data platform, so that they can come and write their queries, get their ETL going, those sort of capabilities, and along with that, some querying capabilities as well.
One even sort of question before getting into data platform, like how would you differentiate a production database with data platform? Like why should one even opt for a data platform where
Correct.
instead of just querying the production database that they already have?
Yeah, I think in the earlier world, when people were developing applications and when they wanted to get insights out of the data that they have collected, they were actually querying the source databases and getting their results and their answers. So now the things have changed drastically with the increasing complexity of the applications, the kind of data sources people use. For example, SQL, NoSQL, and then Excel and whatnot. With all of these things, the complexity of this and also the complexity of the problem that they are trying to solve, the analysis will become complex if they start querying the data from their source, and it becomes costly also. So
Right.
hence there is a definite need for data platform and data lake, I should say, so that the all the data from these data sources can be brought at a central place whereby we can basically feed it to their analytics requirement, and then they can develop insights out of it. So there is a definite need. I think that's
And
already
obviously,
realized.
it would be around the security aspect as well, right? So
Yeah,
if
correct. It's
yeah, so if
it
this
is
will
there.
become a isolated system, which is
Correct. So basically now it will make things easier for let's say ensuring security by ensuring that not unauthorized person should access these data sources. All of the access management should be there at the central place, which is at the data platform, and then
right.
it becomes easy to manage all the users and what kind of things that they are looking at inside the data platform. There will be PII data, and with these the GDPR compliances and whatnot, these things becomes quite important. So yeah, you're right. I think
Right.
security is a very, very important thing.
So I think you spoke about quality, right?
Yeah,
Which is obviously a very important part,
correct.
be it real-time analytics platforms or batch data platforms. Once the
Mhm.
data is flowing in, it's flowing in from an uncontrolled environment where it's actually user-generated, not system-generated most of the times. So from this
Correct.
to getting to the clean data, which Angel can probably use,
Mhm.
how does a data platform facilitate this journey?
Yeah, when you talk about quality, I would say there are a couple of things. One is correctness of the data. Second is completeness of the data. So by correctness, I mean that so
Hmm.
whatever state of the data is in the source, it should be the same state in the destination, which is the data lake or data warehouse. And when we say completeness, the all the records should be there. There shouldn't be any missing records. So those are two quality parameters, and then there will be multiple such parameters. And how do we facilitate this journey in the data platform? So once we ingest our data into the data platform, we have to make sure that the ingestion is complete. Okay, it is not missing anything. Secondly, the frequency and the acid property which which these relational data stores have, we have to ensure that that is somehow replicated in the destination, so that we can have a sort of similar view basically in the delta lake that we have, right? So, so these are a couple of things, and then there are other kinds of quality check which definitely the end consumer would want. For example, null checks and all, the range checks and such sort of things. These are another level of requirements in the quality domain. For
So
that,
basic
we will
set
have
of
to have.
that we
Yeah,
can configure on the columns tables,
correct,
which
correct,
are
exactly.
pre-expected. These I think solves for more than 95% of the use cases, right?
Correct, correct. That make life
Got
easy
it.
for the end users actually. If we have those kind of checks. Yeah.
Like we did bunch of iterations at Udan, right? In data platform, we started from a vendor, then we built internally. All the maturity journey that went into it, data maturity, platform maturity. What would you draw as a takeaway if one is to build data platform internally in today's domain? Should we even go about doing that?
Yeah, I think that is an important question. So I think data platforms as such are maturing quite fast at this point. And secondly, one more thing, the use cases of the data platform have been growing very tremendously. Okay, the kind of use cases that we had earlier, let's say 10 years back, they were different. Now it's more of AI and ML sort of use cases you have to drive with the data platform, right? So there are these with the change of these use cases, the kind of the design that we have to create with the data platform is also changing. Okay. Currently, if we talk about the current scheme of the things, it's mostly delta lakes. But earlier, that was not the case. There were data warehouses people were constructing, right? And then they were utilizing either the cloud vendors, for example, Redshifts, etc., for their warehousing needs, uh, or they would be using Hortonworks or Cloudera, etc. So this is I would say the data platforms are always in transitions. When we started, the requirements were slightly different from what it would be now. Okay, and there are definitely a lot of learnings that we have done on the way. One important learning is cost will always be a very important aspect of data platform. So you will have to ensure that you are cost effective in terms of implementing your solution. Second thing is user centric approach, which is like the data platform has to be a self-serve platform as much as possible with least interaction from the administration sort of guys. And it has to be flexible in terms of, let's say, changing needs of the platform, right? So all of these things you will have to consider. For example, when we created the platform, initially, as you mentioned, right, we were on a different vendor, and then we transitioned and we started exploring different solutions such as Databricks, etc.
Right.
And then we hinged on the Databricks, right? So what we did is we centered around it, and then we created our own platform around it, basically optimizing the data platform for our needs and adding a couple of flexibilities around how do we use Databricks platform for serving our needs, right? So that was the whole intention at that point of time. But if I had to recreate it again, I'll rather try to make it more cloud agnostic as well as these solution agnostic. I'll basically keep a couple of aspects same also. For example, the user centeredness, those things I'll keep the same, but I'll try to make it more flexible to switch technologies, underlying technologies. That is one aspect I will definitely cater now. And also there is one important thing I think so. It has to be more sort of full stack in terms of the ML capabilities that it can serve, right? As you mentioned, right, feature store was added later, and all of those things. Maybe we can keep all of these things in mind before designing the next solution. So, yeah.
So I think one key takeaway that I'm seeing is data platform should be a virtual layer which is capable of switching between backends more seamlessly rather than being vendor specific or cloud specific. And through
Yeah,
that,
it has to be. Correct.
got it. So basically, people should sort of build a gateway which is tuned to their use cases and which they can switch, right? Got it.
Yeah, that was I would say that would be a journey for a company which can build such platforms. For most of the companies, for 80-90% of the companies, I should say building a platform itself doesn't make sense. They should basically address their needs via any of the cloud providers solutions or any other these CDP providers, right? Cloud data platform providers. That should be a better choice for them. Because initially, I think so most of their use cases will be served in a cost-effective manner with them. I think that should suffice.
So let's get into the consumption side of data platform for a bit. So like back then, people used to write SQL queries, and even today they write SQL queries. Then it's exported into a BI engine. Then dashboards are generated. Usually there is a lag. Let's say chosen 6 hours, 1 day, whatever you choose, right? So that versus real-time analytics. What do you see would be the value gain? And Pranjal, feel free to step in. Right.
I think I missed the last part. That when you're finding the difference between the real time and the batch.
Yeah, if we are trying to compare between the batch reporting where people had to write SQL queries back in the day and even now, versus the real-time analytics platforms that are coming in now, where it's more no-code driven, people don't have to know SQL, more business driven, right? So how do you see that affecting data platform, and how do you see this landscape changing? I was just asking if Pranjal, he wants to jump in on the conversation as well.
No, I think see, data platform. I think the data platform will remain there. What is going to change is the consumption pattern, right? Data platform still serves as the data. It still serves as the SQL engine, right, for us. Now, when I talk about like real time consumption, how it is still required today, but I think the solutioning which we have today doesn't serve the purpose, because there are some business needs where probably the executives need that what is happening in the last 1 hour, right? And with current capability, it becomes very very difficult, because we typically wait for a day or 2 days, right, for the reports to get generated. Now there are two angles to it. One is basically you you know how to basically fetch the data, and for an engineer probably that is a much easier option, right? They can hit the dbs and fetch the data. But for a analyst, right, it becomes a trickier problem. So they typically wait on to write sql queries which process the data over 1 or 2 days. Now if data platform matures in such a way that anyone, right, uses just a normal natural language to generate any real-time reports or even batch reports, it would be a much better state from where we are today.
Right. And actually, have you seen this consumer pattern change over the years? Companies moving more towards real-time analytics than batch, or how has it been?
I think still batch use cases are significant in terms of the usage of the platform. Real-time use cases have definitely come into picture, and then they were in picture. I should say, when I was working in Ola, there were a lot of real-time use cases whereby people were trying to catch the erring drivers and all whatnot. Right? There were such use cases there then also, but the percentage of the use cases, I should say, it's slightly growing for the real time, but it the significance is still towards the batch use case. And definitely in terms of reporting, and as Pranjal mentioned, right, it will definitely make sense if you can give a view of the system as early as possible, okay, in real time, on your real time. And secondly, for business users, those who are not, let's say, well versed with the writing SQL and all, for them, if we can have a low code, no code sort of solution, and then maybe utilize the LLMs or etc. to basically construct the queries for them and give the graphs and all for them, I think that makes sense. That I think so is definitely a future for data platforms.
Right.
You write as less
So-
as possible and get maximum insights from that. Yeah.
Got it. Actually, on the topic of insights, so one, I think, very interesting thing that everyone wants these days from top down in any organization is observability, right? It's a big challenge you take whatever domain. So what would you three think of that when it is applied to operations research? What kind of observability would you need in those cases, or to manage a system like data platform, or to manage a entire risk pipeline of an organization? What kind of observability would you require, real time versus batch, as well as the kind of metrics that you would monitor? Alok, if you want to go first.
Yeah, so I'll give you one example, right? Let's say you build a last mile routing system, right? And then obviously you want to see, right, how your algorithms are working and all, right? So
Right.
let's say, yeah, so let's say you are solving your routing for, let's say, 20, 30 cities, right? And then you need to store the output in some place, right? And then you can query and get your, let's say, like different metrics, right? Let's say what is the number of touch points per vehicle, right? What is the vehicle utilization in terms of weight, right? How much time the driver actually took to actually deliver all those deliveries, right? So you need to capture all these numbers, right? And everybody, like from the driver to your like top level management, right? Everybody wants to see how your this, what I would say is like how your supply chain performance is, or like how your supply chain efficiency is being rated, because we always have some type of cost goal, right? So if you don't have this data readily available, right, then how are you going to, let's say, know, right, which city is doing good, which city is not doing good, right? And you need to deep dive, right? So that's how it helps us.
Actually, at the risk of diverging from the topic as well as running out of time, I'm interested in one small subtopic of this.
Okay.
Fuel prod is something that I've encountered a lot of MSMEs have tackled towards, right? Edging on operations research as well as fraud and abuse. I mean, first, what kind of observability should organizations or fleet managers have on something like fuel fraud? And what are some of the ways, if you have already encountered it, people usually deal with fuel fraud? Pranjal, you can answer all along.
I think one use case or one way we have solved this problem is to have anomaly detection right in all the data sources, right, or all the key metrics which we track. For example, I'll give example for fraud and abuse, right? For e-commerce companies, returns is a cost. Now, if you see that in a particular geography or in a particular cohort, all of a sudden the return cost has increased, then probably there's something which has gone wrong. So then an abstraction of that is basically having right anomaly detection at multiple places. I'm just calling from the talking out from the fraud and abuse perspective. From DS point of view, I think DS needs to take care of both metrics. It's not only the output metrics or the product metrics, but even how is model doing over time, right? Because there's a concept called as model drift, which usually happens with all the ML models. And over the period of time, model starts degrading. Now you need to have those things in place, or all those metrics and dashboards in place to track these and like as you go.
Right. So I think first thing would be getting the right tooling into those vehicles that transmit this IoT-based information back to
Yes.
the data center, and then we are ensuring that any drift in this data is probably a fuel fraud.
Yeah.
Probably, Alok, that would also be based on routing, right? So if a
Yes.
van traveled in this specific area, its mileage would be different and all this.
Yeah. Yeah. So like I can give you like one more like fraud use case that I've seen, right? So many times what happens, although the driver will be out of the hub, right? And it is supposed to that like they are delivering, but many times what they do is they will go to their home and then like they will sleep for 3-4 hours, right? And like we have seen that. And that also leads to your RTO, right? Because they will not have time to deliver all the wires, right?
Yeah. Got it. That's interesting.
I think that's a work-life balance.
Yeah.
Nice. Cool. So I think, yeah, getting back to observability problem, I think operations research, Alok has covered it. But to maintain a SaaS company or a SaaS product such as data platform, analytics platform, what kind of metric should one observe? And I think this is going to be completely in contrast with what we have heard before.
Correct. I think, yeah, for a platform, I think the notion of the observability is slightly different. So one critical piece that we have to observe is the kind of infrastructure that we are using, how we have to observe that infrastructure, the kind of CPUs and all, right? They're costly things, and secondly, they have to be very reliable. So the resources should be there, right? So we have to monitor our CPU matrices, we have to monitor our memory matrices, etc. Secondly, we have to monitor our infrastructure such as pods, etc. All the services have to be running. It's all underlying. It's all services, right? Databases, etc. So we have to ensure that these all things are up and running, and the number is also basically as equivalent to what we require at that point of time. Thirdly, in data platform, most of the things are pipelines, right? The data is flowing from one place to another. So we have to ensure that all the pipelines are up and running. We have to make sure that all the jobs are up and running. For example, there are multiple jobs that basically run in background to get things done. So we have to ensure that these are also running at whatever designated time is for that job. So all of these things we will have to observe and basically alert on any sort of anomalies in that case. Right? So the observability is a very critical piece because if you're operating, let's say, thousands of the pipeline, it's important. Each and every pipeline is important. You have to ensure that it works. Right?
Exactly. So I think reconciliation as well as ensuring that data discrepancies are not there between the source and data platform would be the key metric to monitor.
Yeah. I think data discrepancy is very important metrics for data platform. Data is not in usable states, entire pipeline breaks, right? So it's a very important metrics. Correct.
And then the whole equation of fraud, whole equation of operations research is gone if you don't have these basics.
Correct. we are the single point of failure in that case.
Yeah. Got it. Hey guys, this is Sharan. Thanks for watching the podcast. Stay tuned and subscribe for more updates. And this video is brought to you by Perceptinsight.com.